Okay, hello, good evening, everybody. I'm Mr. Chu. Again, I would like to share with you on the technique of how to answer STPM chemistry for semester 1. In the chapter 2, where we are going to have a look on how you're going to answer the essay for electronic structure of atoms. So if you've already buy my module, you can see the questions inside the module. To those who haven't buy the modules, later I will attach the uh, Shoppee apps link so that you can click on there and linked to the app to buy my module. It's a cheap 25 ringgit only, excluding postage. So hope that you all will support. Thank you very much. So without any hesitation, let's begin the lesson today, where we are going to start with the discussion of essay question number 1A. Number 1A sounds like this. Tan's rule, Pauli exclusion principle, and Aufbau principle are used to determine the ground state electronic configuration of an atom. Number 1, state the rules and principles, 3 marks. So what are the rules and principles of Hans rule, Pauli exclusion principle, and Aufbau principles? So you have to learn how to, you have to memorize on the how to define it. So here it shows you directly. So the keywords in here is when electrons are placed in a set of orbital with degenerate, or you say equal energy level, also can. The electron must occupy them singly with parallel spin before pairing. Okay. So that is how you define Hans rule. And then for the second definition, Pauli exclusion principle, each of only 2 electrons may occupy the same orbital with opposite spin. Okay, so then in another word, you say that each orbitals are occupied by 2 electrons with opposite spin. So that is the key word to explain Pauli exclusion principle. And finally, Aufbau principle, electron occupying orbitals in the order of the energy with the lowest, okay, always occupied first. Orbitals of the lowest energies are always occupied first. So the key word must be lowest in here. Cannot say low, cannot say lower, no. Okay, so that is for question number 1A, 3 marks in here. And then number 2, describe how the principle are applied to nitride ion N3 minus as examples. So you are going to making use of these 3 rules and principles to apply to nitride ion. Definitely, first of all, you have to write the electronic configuration of the nitride ion. You have 1s2, 2s2, 2p6, 3s2, 3p6. Then you explain from the angle of how you apply Aufbau principle, how you apply Hans rule, how you apply Pauli exclusion principles inside your filling in of the electronic configuration. So here you are going to explain like this. You're going to first stage from the Pauli exclusion principle and Aufbau. So you fill in 1s, 2s, and 2p orbitals as in like this. So if this is a 1s, okay, if this is 2s, and then you have 2p like this, okay. So you fill in like this, and using the orbitals energy level diagram, orbital diagram, you are able to apply them accordingly. Where starting from saying that Hans rule is only applicable for 2p orbital, where each of these orbitals are occupied first with a parallel spin before pairing. So you must mention 2px, 2py, and 2pz orbitals are filled with electron first before pairing. That is for Hans rules. And then for Pauli exclusion principle, each orbitals are filled with, each orbital is filled with 2 electrons with opposite spin as shown in the diagram. And finally, Aufbau principle, where Aufbau principle stated that there is Aufbau principle, or I didn't have Aufbau principle here, so I just write out in Aufbau principle. Okay, so you have electron filling in from lowest energy level of 1s. to 2s to 2p. Okay, so these are how you're going to explain on how you're filling in nitride ions inside this one. And then last but not least, you also need to explain Pauli exclusion principle. Oh, okay. I think I have it already, but I typed wrongly. Yeah. So in here. Okay. In here. Okay. This is this one. Okay. Okay, so this is how you are going to fill in for nitride ion electronic configurations. So 5 marks inside there, therefore you have 5 points. Okay, B, calculate the ionization energy required to remove 1 mole electron from hydrogen atom which is located at the ground state of the Lyman series. So you have to use all the equations from the Rydberg equation, Planck's equation, and also you multiply with the Avogadro constants. So first of all, in the Lyman series, you have to mention that ground state energy level N1 is equals to 1, while it must reaches N equals to infinity in order to remove an electron. So you apply the Rydberg equation. 1 over lambda is equals to RH times 1 over N1 square minus 1 over N2 square, or you substitute accordingly. So you have 1 over lambda is equals to 1.097 times 10 power 7. Times 1 over 1 square minus 1 over 2 square. Now, just leave it as 1 over lambda, because you will apply it to E equals to HF or E equals to C, H times C over lambda. Okay. So in here, just straight away multiply the energy per electron using Planck equation. So you have Planck constant. This is the Planck constant, which is the H. And then this is the speed of light C, and this is actually 1 over lambda that we calculated just now in here. Okay, so no need to don't need to solve the 1 over, because at the end of the day we're still going to use 1 over in our calculation. Or you straight away press your calculator, you get 2.18 times 10 power negative 18 joule per 1 electron. So this is the energy required to increase the energy level by 1 electron here. Okay, then you shall have then followed by delta H is equals to the energy times the Avogadro constant. So you have 2.18 times 10 power negative 18 times 6.02 times 10 power 23. The purpose of divide times 10 power of 3 is to change from joule to become kilojoule. That means actually you don't really have to do this. You leave it as a standard form also okay. You leave it as kilojoule per mole also okay. So that your delta H is equals to 1310 kilojoule in 3 significant figure. Or you can also place as 1.31 times 10 power of 6 joule mole minus 1. Okay. So that is how you're going to apply this how to calculate ionization energy for electrons in the Lyman series. Okay, with that is for number 1. Immediately we go to number 2. The number of electrons occupying different orbitals of atom P are shown in the table below. So you have S orbital has 8 electrons, P orbital have 12 electrons, D orbital have 5 electrons. Write the electronic configuration of P and explain how each of these orbitals are filled with electrons. So this question might seem a little bit difficult, but it's actually not. All you have to understand in here is what are they trying to tell you from the table is in here, even though they say S orbital, but it doesn't mean that it is single S, because some of you, hey teacher, why S orbital? I thought S orbital can occupy 2 electrons only. So why is it now 8 electrons? Of course, this is not only one S orbital. It may be made of 1s, 2s, 3s, and also 4s. So altogether 8 electrons. So that's why you have 8 electrons in the S orbital. So that is what it means. As for P orbital, why 12? Because you have 2p. Each p occupies 6, isn't it? So 2p and 3p. So 6 plus 6. That's why you get 12. And then D orbital is 5. Then so you can more or less imagine on what is the electronic configurations of the atom P. Now there is an alternative way if you are already familiarized with the way after you know the electron, how you are going to fill in the electronic configuration. Okay, so all you have to do is just total up the number of electrons. So 8 plus 12 plus 5 is equals to 25. So once you know that you already have 25 electrons, you can straight away write the electronic configuration of P as follows. You have 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2. As you can see from here, the total number of S is electron in S is 8, total electron in P is 12, total electron in D is 5. So that is why they ask in the form of tables such as like this, so that to confuse you for a while, but once you understand the principle behind the question, shouldn't be much of a problem. So now, then the question also asks you explain how. So if the question asks you to explain how are you going to fill in the electronic configurations? Definitely is by using the 3 rules and principle, which are Aufbau principle, Hans rule, and Pauli exclusion principle. So these 3 are very, very common. Just write each of their rules and explain how they are filled. Definitely you can get 7 marks easily. Okay, so for example, you say that electron filling in from the lowest energy level, or from 1s to 2s to 2p to 3s to 3p to 4s to 3d, according to who? According to Aufbau principle. Okay, so this is how you write. And then each orbital is occupied by 2 electrons with opposite spin, according to who? According to Pauli exclusion principle. And then last but not least, you also have to explain that each in the degenerate orbitals, 2p and 3p. Okay, if possible, you try your best to mention which orbitals has 3 degenerate orbitals. So also mention 2p and 3p, and also 3d, for example. Okay. So electrons are filled singly with parallel spin before pairing. Okay, so according to Hans rule, so each S and P and D orbital can have a maximum of 2, 6, and 10 electrons. So this is just a bonus marks inside here. Once you write until this point, okay, it's already 7 marks already if you look carefully. Okay, so with that, that is how you explain based on the rules and principle how you're filling in electronic configurations. Okay, next we have sketch emission spectral for the hydrogen atom for Lyman series. From the diagram, sketch explain the trend of successive spectrum form until convergence line. So 5 marks in here. So the question requires you to sketch until the convergence line. So what is the emitter spectrum of the hydrogen? So it is the line graph like this. Okay, so axis with frequency and wavelengths. Okay, so you try your best to describe as much as you can. So in this spectral line emission, so you have to mention that in here the frequency increase accordingly. Okay, or you say wavelength decrease, either one, but you must mention this one. This one is very important. Okay, so you must have the line starting from the first line, which is the furthest. Then you have a second line, you have a third line, and you have fourth line, and you have so on line until what we so-called until it reaches the convergence limit. Okay, so this is how the spectral line is formed. So you also have to explain as the energy level increase, you can see that the differences become smaller, or we say that the spectrum line is consists of decrease, eventually converge. Okay, so with that, that is how you are going to explain, sketch and explain the trend of each successive spectrum form until the convergence limit line, 5 marks in here. And number 2, calculate the frequency of the second line in the Balmer series sketch. So in here you just use n1 equals to 2 and n2 equals to 4. So f is equals to c over lambda. So 3 times 10 power of 8 multiplied by 1.097 times 10 power of 7. 1 over 2 square minus 1 over 4 square. So in here is a combination between the frequency equation and also the Rydberg equation. So you can straight away combine and calculate because it's only 3 marks. Okay, so therefore you have f is equals to 6.17 times 10 power of 14 second minus 1. Okay, so with that, that is how you answer for essay question number 2. So hopefully you'll be able to understand what are the equations that you use. Then straight away we go to question number 3. When excited electrons fall from a higher to lower energy level, the excess energy emitted as a radiation. Using suitable energy level diagram, state and explain the energy level transition that can produce Balmer series. So this is a very important keywords. You must use energy level transition to explain Balmer series in the emission and give 3 characteristics of a series, 7 marks. So you have to use the energy level diagram. Okay, so Then you sketch all over. Now, minimum must have at least 3 or 4 energy levels so that you can see this one. And then whenever you sketch the energy levels, try your best. Between here and here has the widest gaps. Okay, has the widest gap. And the gap eventually becomes smaller and smaller with the increasing of the energy level. So try your best to draw in such way. Okay, so that is how you're going to draw for energy level. And then what are the 3 characteristics? Number 1, electron transition from any higher state to lowest energy level, which is n equals to 2. So because it's Balmer series, so electron transition occur in the visible light. Okay, so that is a characteristic where the baseline is n equals to 2, so also mention that. And then as the spectrum consists of the discrete line or separate line, and as the frequency increase, the line converge. Okay, so obviously it become closer together. So all these are characteristics of this one. So the graph itself is 3 marks. So each of the statement in here is 1 mark. So altogether 7 marks in here. Okay, so I also need to label the energy level diagram in here because it's energy level diagram. You must label as energy, please. Okay, so that is how you answer for 3A. Then we goes for 3B. Compare the emission spectrum of hydrogen in Balmer series with that alignment series. So in here, you can use a table form if you want to compare. I think that will be very, very clear if you use a table. So for example, what are the light source? What is the ground state energy level? Which one has a higher frequency or lower wavelength? And then last but not least, what is the productions, what can you use to do the things? Okay, so for Lyman series, the ground state energy level N1 is equals to 1. For Balmer series, ground state energy level N1 is equals to 2. So Lyman series is produced under the radiation of ultraviolet light, whereas the Balmer series is produced under the radiation of the visible light. So Lyman series can be used to calculate the ionization energy of the Lyman series, whereas Balmer series can be used to determine the frequency of the light. And finally, Lyman series usually has a higher set of frequency compared to Balmer series. Or you can also put it in the form of wavelength. Lyman series usually have a shorter wavelength compared to Balmer series, which usually have longer wavelength. Okay, so with that, each of the comparison will be 1 mark. So altogether 8 marks in here. So this is what you can only compare for the Lyman series and also Balmer series. So hopefully you'll be able to write. In STPM question, you can express your answer in any form that you feel that is comfortable for you. For example, you can fill in the form of table, you can fill in the form of graph, you can fill in the form of whatsoever, as long as if the question asks you to explain, then you explain. Okay. Okay, so with that, that is for question number 3. Immediately we move to question number 4. Explain the meaning orbital followed by the description of the shape and symmetry for S and P orbitals, 5 marks. So what is actually orbitals? Orbitals are spaces with high probability to find an electron. So this is how you define what is an orbital. Okay, orbital are space with a high probability to find an electron. So that is the first mark in here. Then you have to draw the shape and shape for the S and P because you have to describe. So S orbital is a spherical orbital shape which located along XYZ axis, whereas P orbitals is a dumbbell shape located at 3 different axes, namely PX, PY, PZ. So each of them 1 mark, and definitely you cannot lack of diagram if you want to express them better. So that is how you're going to explain what is orbital and what are the shape and symmetries of the orbitals mentioned. Okay. Okay, so that is for question number 4A. Then we have 4B. Iron with proton number 26 is useful metal in lot of industry, especially in industry of large building and tower. Number 1, write electronic configuration of the iron atom. So you must know that iron must be 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. Okay. And number 2, based on the answer in number 1, write a valence equation for iron 2 and iron 3. Explain which one is more stable. So definitely iron 3. Iron 3 is going to be more stable. Why? Because it has a half-field d orbital, which is has extra stability. Okay. Okay, and last but not least, you must also have says that another metal Q added to iron to increase the resistance of corrosion to iron. Metal Q is isoelectronic with iron through ion. So name the metal Q and write electronic configuration. Hence, compare the arrangement of 3D and 4S between metal Q and also iron 2. So in here, you have to first write out what is, identify the metal Q. So metal Q is chromium because Q already, the question already said Q is isoelectronic with ion. So when we say isoelectronic means that same number of electrons. Okay. However, in terms of writing electronic configuration, the way of how to write electronic configuration is going to be different. Okay, so electronic configuration of the atom Q is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. And then you also have to mention that metal Q has a half-field 3d orbital, which is more stable. So that is why when they say isoelectronic, you must know that they have the same number of electrons, though they have different arrangement. So while Fe2 plus has a partial field 3d orbital, and 2 electrons will move from the orbital according to the Aufbau principle. Okay, so that is how you are going to explain what happened if, to the metal Q in here. Okay, so with that, that is for question number 4. Then we go to the final essay question, question number 5. State how ionization energy of hydrogen can be determined by electron bombardment. First of all, you have to explain photon energy is absorbed by the hydrogen atom. Therefore, electrons in the ground state excited. Then you have to also explain when it reaches the convergence limit, the line converge. Okay. Hence, the electron is removed or ionized from the hydrogen atom. Okay. And therefore, these are the frequency, energy level, spectral line for the emission of hydrogen atom in Balmer series. Okay, so it falls to the ground state energy level at n equals to 2, and electromagnetic radiated hence forms spectra which consist of discrete line and blah blah blah. Okay, so sorry, because that is how you are going to describe things. Okay, so that is for question number 5b. And then number 5b2, with the reference of information, calculate ionization when 1 mole of hydrogen atom is in Balmer series. So this question is very resemble to that of this question number 1 earlier that we discussed. So use F is equals to C lambda since you already have you want ionization energy, so you have to calculate accordingly. 3.65 and 10 power 7 is previously you have 1 over lambda. Okay, you have 1 over lambda time equals to RH times 1 over n1 square. Okay, minus 1 over n2 square. So you substitute accordingly. So you have 1 divided by 1.097. Okay, then you multiply by the Rydberg. Hey, I don't have a equation. Sorry for that. Hey, sorry. What am I talking about? 1 over lambda is equals to RH, or 1 over lambda is equals to 1.097 10 power 7. 1 over 2 square minus 1 over infinity. So that is how you are going to apply. Then you put it inside here, then you get your F. Then you calculate C is equals to HF, you calculate accordingly. And finally, delta H is equals to E times Avogadro constant. So you get your final answer as 3.28 times 10 power 5 or 328 kilojoule per mole. Okay. Okay, so chapter 2 more or less, these are the questions. If you look carefully in the trends, actually back and returns, they are almost the same style. They ask about how do you describe the line spectrum from the energy level diagram, and then they ask you about how to calculate ionization energy using suitable equations, how do you, what is orbital, what are the shape of S and P orbital, and finally how to write electronic configuration. So once you're able to master all this, chapter 2 shouldn't be much of problems to all of you, okay? Still, if you have any question, you can always leave your comments through my YouTube, and I will try my best to solve for you. And if you like this video, please click the like button and share it among with your friends. And if you wanted more information in the upcoming video, you can also click subscribe, and don't forget to hit the bell button for further notification if I ever posted a new video in here. So I guess that's all for my video today. So I'll see you all in my next lesson next week on chapter 3. Okay, so see you all next week. Bye. Have a nice day.